Hi folks, welcome to our next session where we're going to be talking about some fieldwork practices for fluvial landscapes. Now, during our Zoom meeting together, we had the chance to describe this idea of streams, right? Being a word to describe a flow of water that is driven by gravity in a natural channel in the land or terrestrial environment. So we're going to keep using this word stream to talk about rivers and small rivulets, large and small. When we talk about streams in our geography class, we looked at this idea of different stages of a river, whether it's in its youthful, intermediate, or mature stage. And we also had you describe some different channel patterns that often form in these different stage environments. You can see. But when it comes down to fieldwork and observable patterns on the land, our textbooks are often asking us to describe differences that you can see between two types of rivers. And so the question arises, how can we describe these differences in river and stream features? So I hope through this session and activity, you'll gain a little more content that you can use to describe streams and rivers with your students. Now, one way that we can think about describing these systems is trying to break them up into different divisions or segments. And so this idea of valley segments and channel reaches, these are units which we can use to describe our fluvial landscapes. We talk about these units because they are the largest physical subdivisions that can be directly altered by human activities. And therefore, it's useful to understand how they can respond to our disturbance. We want to know about these things because it gives us a chance to describe physical changes that we can observe. And those descriptions can allow us to make comparison between these different units and notice if there's been any change. And ultimately, if we can describe some of these features, we can determine the suitability of our streams for any type of channel modification, whether that be for industrial purposes or restoration or animal habitat. So we're going to start by focusing on this idea of these valley segments. A valley, in a broad definition, is just where a place where water converges and eroded material accumulates. Valley segments are described based on their dominant sediment inputs. And typically we have three types of valleys. First being colluvium, with colluvium meaning sediment that's accumulated through mass wasting, as in through landslides or any of those other debris. And so in colluvial valleys, water-based transport of sediment is really limited. And we have either unchanneled, which are like those soil-mantled hill slopes, or channeled colluvial valleys, which have just beginning headwaters of streams. So in these types of valleys, flow, if any, is very shallow and ephemeral at different times, intermittent. The other end, or similar end of the spectrum, is bedrock types of valleys. And bedrock valleys are the ones where there's little fill material and they possess confined channels that lack any alluvial bed. There's no accumulation of bedded clasts within our channels. And so this excavation is often by debris flow in our bedrock systems. But in the middle, we can talk about these things known as alluvial valleys. And alluvial valleys are dominated by alluvium, or sediment that's transported along the valley floor by stream flow. So alluvial valleys have sediment that's supplied from upstream sources and different waterways. And they're capable of sorting that sediment in erratic patterns. We can describe our alluvial valleys as either being confined into usually by geographic and geologic controls, or unconfined. And those are ones that can have well-developed floodplains. Now, it's within these alluvial valleys where we can get very interesting features called channel reaches. And these types of channel reaches develop. These channel reaches can develop in our other types of valleys as well, but we most often see them and can describe them within alluvial systems. So let's take it down. Let's see, what are these channel reaches? We can describe a channel reach as a repeating sequence of specific types of channel units and characteristics. Often we describe reaches as being somewhere between 10 to 1,000 meters squared. So observable units, but that stretch for a long thing, for a longer distance. We define these channel reaches by their morphology. And remember from our study of hill slopes, morphology means the shapes, so the shape of the reach, as well as a sequence of channel units. And by channel units, we mean these discrete, smaller features that you described when talking about your larger patterns. So some of these units might be specific bars, steps, pools, and riffles that you can observe within the water. So we look for channel units, these small observable features, and we look for the sequence of these channel units to describe what type of channel reach we are observing. And we can differentiate and classify channel reaches based upon what units are present. And so this breakdown of different types of alluvial reaches really follows some specific patterns going from upstream to downstream, where you see different reach types being more prevalent. Ultimately, the type of our channel reach is going to be dictated by both the supply and characteristics of the sediment that's present, as well as the power of the stream. And that power, again, comes from the flow velocity, which is directly related to the steepness, the slope and gradient of our river. So I'm going to briefly take you through a few of the different types of alluvial reaches that you can describe in different rivers. And then I'm going to give you a chance to see if you can see any of these outside in Bhutan. We'll start by talking about alluvial cascade reaches. And cascades are typical of mountain settings. Often you're going to find them in the steepest channels with grades between 4 and 25%. And what's characteristic is that water in these situations tumbles around, over and around boulders, large clasts that are entrained within the bed of the river. So again, bed load, so it's dominated in an alluvial system. There's clasts that are present, but these are large and water is tumbling around them in a very jumbled sort of manner. Now, oftentimes in these situations, you may get debris flow into the river, but transport of these clasts is predominantly fluvial. And what's really typical is that you can see these large clasts protruding through the water. So these are our cascade features. The next type of reach you can describe is one known as a step pool feature. And you might have seen these in other places in Bhutan. This was a picture taken in Tsaluna Valley just above Kasarapchu, south of Thimphu, which has a really typical step pool feature. And in these types of reaches, we have steps that separate low flow pools. So you'll see these, we call them longitudinal or crosswise steps that are formed by very large clasts, and then they span across the whole entire channel. And in between these steps is where you get these pools of shallower or calmer water, and those pools have finer grained material in between. A typical step pool reach would often have one of these pools for every 1 to 4 channel widths. Bit of a ratio. So these happen in grades that are still steep but lower than cascade features. The next type of channel reach is one that's known as a plain bed reach. And here we have long stretches of rather featureless beds, not any development of point bars or internal situations, but we're typically composed of cobbles and gravel that accumulate on that stream or river bed. Oftentimes you can get occasional large objects like boulders or woody debris that will form localized pools and bars. But the main thing to realize, right, is that these are featureless. We're not seeing cascades, we're not seeing step pools, and just planar and plane flow. And you can see in cross-section and planar view what this would look like as well. So these are your intermediate reaches, typically of grades from 1 to 4%. And again, they're intermediate between our high-flowing cascades and our last reaches, which we'll look at right now. Pool riffle reaches are typically what you consider when you're looking at the meandering sort of streams, where you get these undulating beds and lateral progressions. They have a combination of units in between bars, pools, and riffles, and they're typically graded from 1 to 2%. So our bars, which form on the interior of beds, pools forming on those exteriors, and when you get those transitions, that's where you get these riffle sections in between, going along those river bends. So oftentimes our pool riffle systems are very typical of lower lowland valleys. So when you think of the large rivers flowing through the more open valleys within Bhutan, you can often find some of these pool riffle reaches. One of the lowest flow types of reaches we can get are ones that are called dune ripple reaches. And these typically occur in rivers that only have rivers and streams with sandy beds. So very low flow, low class size. And what happens is along the beds you get these interesting patterns that form, like ripples, waves, and dunes, depending on the class size and the amount of flow. Again, very low gradient streams, so very shallow types of slopes. But then they can vary with different flow depth and velocity of what this will actually look like in between. Our last type of reach that you have all described and familiar with are what we know as braided reaches, where that braided morphology becomes very apparent. And these systems happen when we have a very high influx of sediment supply and only a moderate gradient, so therefore a low transport capacity. We cannot excavate or transport all of this influx sediment, so oftentimes our reaches become choked and develop these braided systems. So ultimately, this channel reach morphology, it follows a typical downstream trend of sediment supply and channel slope. And so the sequences of channel types along a river may reflect both the local and overall slope conditions. And so you can derive some important inferences based upon what type of reach you are seeing. If you observe a cascading reach in a system, you can infer that the slope here has to be of higher degree, and there can't be too much sediment being supplied in. And actually, it's being transported rather quickly. However, once you get down into these pool riffle areas, you know that the river slope, the channel slope, must be leveling out and shallowing. And therefore, we have a higher sediment supply, allowing the development of these different types of units, like bars and pools in between. And again, our intermediate stages are where we get the plain bed features, where we have intermediate slope and intermediate supply, really looking at transport. So your types of reaches can help describe your upstream to downstream trends. This was a very brief overview. Hopefully these pictures help. Oftentimes the words can be counterintuitive, but when you see these things, either in picture or real life, you can start to backtrack and make some of these inferences. So I'm going to share the readings where I got this information and I've developed this lecture from, so you can reference on your own. But to gain some practice, what I'm going to have us do is to try to see if we can identify some of these features in the field. So what I'm going to ask you to do over these next few days is to identify a stream in an alluvial valley near your home. Now this can be a big channel stream like a river, or else it can be a smaller rivulet, but just somewhere where water transport of sediment is our dominant system. And I'm going to ask you to go out and complete the following observations. I want you to try to identify a reach, right? So a longer stretch of this river, and try to classify this channel reach based upon its observable units, its sequence of units. If you can see pools, if you can see riffles, if you can see bars developing, and trying to classify that, okay, would this be cascade? Would this be step pool? Would this be a plain bed system? And then, once you've made that classification, I want you to think about what you can infer about sediment supply and channel slope based upon that classification. So, for example, if this is a picture that Duwashser sent us of Samsi in the Damtum area. And so if I was looking at this reach of the channel, I can see that we have, it's relatively featureless, right? I don't see any cascades or step pools, but I do see an intermediate amount of flow. And actually some isolated, I think, man-made areas that have created small pools in the river. So I would classify this type of reach as a plain bed system with intermediate sediment influx and intermediate flow. Now, rather than just posting these observations on VLE, I have created a new survey form where you can fill out these observations. And so you can do the survey form either on your mobile, or you can actually head to your computer, and you'll be able to click this survey and then add in your different points. I'll make a short video to describe how to use that survey as well. But by the end of this, as a class, we'll be able to assemble a map of some different examples of channel reaches in Bhutan that hopefully we can use as a teaching tool for classes to come. Okay, I thank you again for your participation, and I look forward to seeing what observations of channel reaches that you can come up with. Good luck, and stay safe.